Well, hello everyone. Today we continue our discussion on using exponential and logarithmic functions to develop equations and to solve problems in real life situations. For example, John opens an account with 1.2% annual interest compounded monthly. How long will it take for the balance to double? Here we are using the formula A of t, or just A, is equal to P times 1 plus R over N raised to the NT. Notice there's an N here in the denominator and there's an N in the exponent. The interest rate is 1.2%. As decimals, that's 0.012. It's compounded monthly, so your N is equal to 12. We do not know exact values for A and P, but we do know the relationship between A and P, because for the amount to double, the remaining amount will be twice what you started with. So A is equal to 2P. And we plug these into the formula. So for A, instead of A, we will write 2P equals P times 1 plus R, we know is 0.012, over N, we know is 12. Raised to the 12 times t. So our objective here is to try to find t. So we're trying to find t. So let's do a bit of algebra. And we have an unknown p here, but we can undo this p by dividing both sides by p. And so we're left with 2 is equal to 1 plus 0.012 over 12 raised to the 12t. Now, what we can do next is that we can now take the ln of both sides. So if we take ln both sides, take ln, we will have the ln of 2 is equal to the ln of 1 plus 0.012 over 12 is to the 12t. Then we will use the power law to bring this 12t over. So we have ln of 2 will be equal to 12t. And 1 plus 0.012 over 12. Do not forget the ln right here, so that's the ln of it. And then what we can do lastly is divide through everything by everything except your t. So your t will be equal to your ln of 2 all over your 12 times ln of 0. Don't forget the 1 plus 0.012 over 12. So that's it for your workings. The rest is your calculator work. Just plug that into your calculator and you will get roughly 57.012 years, and that is the amount of time it will take for your whatever balance you put in to double. Okay, now let's look at another example. Another example we should look at is Jill wants to open an account which the balance will triple in 50 years. The interest is compounded weekly. What should the interest rate be? So in the previous problem we solved for time. Now we will be solving for a rate. We use the same formula. A is equal to P times 1 plus R over N raised to the NT. A, we don't have a specific value for. P, we don't have a specific value for. Again, but we know that your final balance will be triple or 3 times the amount you started with. So A equals 3P. Your N, you're compounding weekly, so N equals 52. Your time is 50 years, so T equals 50. Plug in these into our original formula. Replace A with 3P. P remains P. 1 plus R over 52 raised to 52 times 50. We do a bit of algebra, divide through both sides by P. We end up with 3 equals 1 plus R over 52 raised to 2600. That's what you get when you multiply 52 by 50. Then we use the similar steps to what we did previously, where we apply ln to both sides. So we have ln of 3 is equal to ln of 1 plus R over 52 raised to the 2600. Then we apply the power law to bring this 2600 forward. Then do some algebra, divide both sides by 2600. We have ln of 3 over 2600 is equal to ln of 1 plus R over 52. We want to get to R, but there's an ln in the way, so we have to apply an e. Okay, we apply an e to both sides, so we have e to the ln of 3 over 2600 is equal to e to the ln of 1 plus R over 52. Because e and ln are inverses, we eliminate this, or they cancel out. So we have e to the ln of 3 over 2600 is equal to 1 plus R over 52. Doing some algebra, if we subtract 1 from both sides and then multiply by 52, we have R is equal to 52 times e to the ln of 3 over 2600 minus 1. And that gives you 0.02, maybe 19 something something. That's about 0.022, or our rate is 2.2%. Now note that we could have probably simplified this a little bit more, the e to the ln of 3 over 2600, but it's fine. We can just also plug it into our calculator just as is, without simplifying it that much more. And just to get to our final answer, because we're looking for a numerical value. And the calculator can hold this, so that's fine. The final example we should look at is a problem given f of x is equal to negative 5 plus ln of 3x plus 1. Determine the inverse of this function. We're still in section 3.5 on logarithms. And also determine that the function composed on its inverse, or f inverse of x. What do we get when we do that? And determine the f inverse of the f of x, and also determine the domain and range of the inverse. What we want to do is that we want to follow the steps of finding inverses that we learned previously. So if we have f of x is equal to negative 5 plus ln of 3x plus 1, we want to just go ahead and replace f of x with y in our first step. So y is equal to negative 5 plus ln of 3x plus 1. Then we want to interchange the x and the y. So where you see y, you replace with x, and wherever you see x, you replace with y. Only, just exactly as they are, right? This way we're interchanging the domain and range values, and so we have a different function. Then we want to try to solve for y. The third step, you're trying to solve for y, so we're doing some algebra. Plus 5 to both sides, so we have x plus 5 is equal to ln of 3y plus 1. We want to undo this ln, so we apply the inverse function, which is e. So we have e to the x plus 5, e, or raised to the x plus 5, is equal to e to the ln of 3y plus 1. Now, because e and ln are inverse operations, they undo each other, cancel each other out. So we're left with 3y plus y plus 1 on the right side, and e to the x plus 5 on the left side. Doing some more algebra, we have subtract 1 from both sides. We have e to the x plus 5 minus 1 is equal to 3y. And then we're trying to get y by itself. Divide So we divide both sides by 3. So we have y is equal to e to the x plus 5 minus 1 over 3. Final step, which you must do, is replace your y with f inverse of x. So all we're doing, we're just replacing wherever we see y. We put f inverse of x for that notation purpose. And so f inverse of x would be equal to e to the x plus 5 minus 1 all over 3. Now the next steps, we're trying to find the part B. We're trying to find the f of the f inverse of x. So that means our f inverse function will be an input into our f function. And so this becomes negative 5 plus ln of 3 times e to the x plus 5 minus 1 over 3 plus 1. What we will be doing then next is doing some algebra to simplify this as much as possible. So 3 cancels out 3, so we have negative 5 plus ln of e to the x plus 5 minus 1 plus 1. Minus 1 plus 1 cancel each other because the inverse operation are the same magnitude. So we're left with negative 5 plus ln of e to the x plus 5. ln and e are inverse operations, so we're left with under each other. So we have negative 5 plus x plus 5, and the negative 5 and the plus 5 cancel each other out. So we're left with x, which is what we expect when we take a composition of a function on its inverse. Next, let's do part C, f inverse of the f of x. So we're taking the f inverse of negative 5 plus ln of 3x plus 1. So wherever you see an x in our f inverse function, we plug in that negative 5 plus ln of 3x plus 1. And so that becomes e raised to negative 5 plus ln of 3x plus 1 plus 5. The minus 5 and the plus 5 will cancel each other out in the exponent right here. So we're left with e to the ln of 3x plus 1. E and ln are inverse functions, so they will cancel each other out. So we're left with 3x plus 1 minus 1 over 3. The minus 1 here and the plus 1 cancel each other, so we're left with 3x over 3, and our final answer after 3 cancels 3, we are left with x, which is again what we expected. Finally, we want to find the domain and range of the inverse function. F inverse of x is e to the x plus 5 minus 1 all over 3. Quick way to do this, just separate this into e to the x plus 5 over 3 minus 1/3. And you'll notice here this minus 1/3 is your new asymptote, or new horizontal asymptote. And remember that for exponential functions here, they're increasing, which is in this case like e to the x, then we start at the asymptote upwards for the range, and your domain is always negative infinity to positive infinity. So your domain is negative infinity to positive infinity. The range is negative 1/3 to infinity. Now, a longer way to find the domain and range is to look at the inverse or the original function, and note that the domain of the original function is the range of the inverse function. The domain of our original function f of x occurred where 3x plus 1 was greater than 0. If you solve for x, you would get negative 1/3 to positive infinity. So therefore, the range of f inverse of x, which would be negative 1/3 to infinity, which we have shown by looking at the original the inverse function itself. And then our range of our original function was negative infinity, positive infinity, which becomes the domain of our inverse function. So 2 ways of doing it, and hope that you're able to see through all of this. And thanks for watching. Please remember to like and subscribe, and see you next lesson. Thank you.